180 cu ventilație, da. Well, hello there. Welcome to this particular sessions of computer networks. How have you been? How's staying at home? What do you mean boring? It's supposed to be fun and entertaining. I'm sorry about that. Had a little bit of a late night. Tried to finish a book, didn't get to it, but I'm going to do it tonight. I just have about 50 more pages to go. So we're going to wait for about 1 or 2 more minutes to see if anyone else joins up. And then we're going to go through the material for today's lab. Today's lab comes with a bit of a surprise in the sense that today's lab does not involve any homework. It's the Easter Bunny's gift to you all. But you don't have to worry about it. When we come back, there'll still be homework left for you to do. Another little bit of an announcement. We decided that this entire lab will be held online. So even if we're going to restart school and that, we're going to try to finish all of the subjects on the virtual campus in this particular method, so as people, well, if we go back to school, then we'll be there. But the idea is that we can finish all the labs in the virtual manner. Not the way we actually wanted them to, but oh well, this is what we can do. How's the pandemic treating you? Besides it being boring. I think anyone else will join us? Okay. So we're going to start. Since there's few of us, we're going to go through the material relatively fast. Tell me, and in order to make it even faster, I'm going to ask a question. Uh, did and this I'm sorry, but I'll need an answer from all of you. Have have you ever configured a Wi-Fi router? That's one answer. Alex? Petronella. Ah, there's six of us. Sorry, I didn't even notice that there's more of us. I'm truly sorry. So more people have joined. Ain't that fun? So again, next to yes-ish, okay, not really, okay. Okay, so as you might imagine, this lab was supposed to be done later on in the curriculum. It was supposed to be the last lab that we do at school. It was supposed to be the lab that finishes and summers up the entire purpose of the education. Now we decided to move it here right before the holiday because, well, it's an easier lab. It's not much, there's not much information there, and so that you go into the holiday with, clear clear conscience of having to do no homework whatsoever for this particular topic. Uh, you will, however, find questions on it on the exam and so on. Sorry about that, but that's the situation. Okay, so as you recall from all our previous sessions, it's my duty to inform you that this session is being recorded, and so if you do not wish to, uh, you know, see yourselves, please turn off your cameras, not let anyone turn them on, and try to pay attention as we're going to go through the material at a relatively fast pace because it's not that much of a big deal. So first of all, we're going to the virtual campus. On the virtual campus, you'll see here that you have wireless networks and Wi-Fi. This is hidden, don't worry about it, it's just a picture. You can access the radio spectrum that we're going to talk about. I'm going to minimize this so it's easier to move around. And over here, you can see the way the radio spectrum looks in the US. We're going to talk about it in a little bit. What else do you have here? You have here the slides that we're going to discuss, a document portraying the radio spectrum in Europe. It's not a graph, not a pretty picture like the one you see here. It's just an interesting topic to see how people portray and how they write about about the radio spectrum. And here you have two links regarding mobile evolution. Uh, and you've got one from Stanford University and one from Gemalto. This is one of the major producers of telecom equipment nowadays in the world. And you have here a small description about the generations of mobile networking starting at 1G, 2G, 3G, 4G, and 5G. The information is somewhat similar, but not exactly the same on in both situations. Now, today, as you might have guessed, we're going to talk a little bit about Wi-Fi. Now, most of you are familiar with it, at least in the sense that you access it, that you use it on a constant basis. We're going to talk about wireless networks in general, namely mobile data, infrared, Bluetooth, and Wi-Fi. We're going to look at a Wi-Fi analyzer, and you'll have examples of a few others. And we're going to go a bit over a wireless router config. It's the thing that you should have done in the lab, and it's not possible right now. Hopefully, by the end of the holiday, I will attach a small movie, YouTube clip on the virtual campus in which you'll have a well, a demo, not a live demo, but you'll have a demo of how you can access certain configurations on a particular router, on the one that you should have done the work in the lab. So first of all, we talk about wireless networks, we talk about mobile devices, we talk about phones, and then we talk about speeds. When we talk about speeds and phones, you'll have them here. You can see that 4G as the proeminent technology that is used today has peak speeds, that means maximum speeds of 1 to 300 megabits per second, sorry about that. And that's about it. 5G has a little bit more. 5G also has some specifics regarding latency, and that is why it's used and why it is in demand. The next type of wireless technology is infrared. Ever seen an infrared device? Sorry about that. Hello. Yo, open chat window. Why isn't the chat window opening? Oh well. Oh, maybe if I, yeah, exactly. Old phones had infrared. Now, why isn't that popping up? That's it. Finally. Yeah, old phones had infrared. It's important to know that you can have computer networks on infrared. It was one of my colleagues' um, degree paper, and he made a network of about 4 computers using infrared. You can see here it has some advantages and disadvantages, namely the greatest advantage is the speed. You can still see my screen, right? Because I clicked around a lot. Okay, so you can see that the speed is the greatest advantage since it goes up to 512 megabits per second. However, it has 2 major disadvantages, namely the distance. You can't get that speed at an awfully big range, and there is an angle. If you remember, on the old phones, you had to align the 2 phones in order to transmit information from one to another. Now, if that angle is more than 15 degrees on each side, so that's a maximum of 30, then you get what is called a break in the line of sight. So the 2 devices, the emitter and the receiver, no longer see each other correctly, and thus the link is broken. But again, huge speed. One of the next technologies that you might have used for data transfer and know that it is useful today in computer networks is Bluetooth. Now, Bluetooth has a lower data rate. You can see that it only goes up to about 24 megabits per second. However, the range is bigger, and we have 2 problems with it, namely the channel interference. You'll see that it uses a frequency band of 2.4 gigahertz, and we're going to come back to that band, to that frequency band in a moment. But the most advantageous part is the distance. And keep in mind that Bluetooth devices nowadays are no longer used for simple file transfers, in the sense that, let's see, in the beginning, we used Bluetooth to basically transmit files from one phone to another. Then we used it to connect our headphones to computers, laptops, and mice, and keyboards, and so on. And those were basically one-way devices. Granted, modern headphones have the capability of having some buttons on the headphones, for fast forward or skip or volume up and volume down, and those send some information back to the devices, however, not that much. However, there are devices that use a lot more bandwidth and a lot more information. And you can think about Oculus Rift or the PlayStation VR. Now, not only do these receive information from the devices that they're paired with, in the sense that they receive a lot of information from it, because when you put on a PlayStation VR or a Google or an Oculus Rift, you are immersed in what is called augmented reality, and you see what the device wants you to see. And the feedback that you provide is the head movement. So the more you move the head, that information needs to be transmitted to the device, and it will change the image or the picture. All things clear up to this point? The Bluetooth has connected successfully too. Okay, back to this. Now, the last type of technology that we're going to discuss, sorry, sorry about that, is Wi-Fi. Now, Wi-Fi is something that most of you should be familiar with, again, since you probably use it on your phones, laptops, even computers nowadays, and it has a few characteristics. The most important of which is the following. It has a distance of about 100 meters, a radius, from the center to all the way around. That means you can have an edge communication of about 200 meters, which is kind of a lot, and it covers pretty much, apartments, gardens, homes, stuff like that. The Wi-Fi is a trademark. As you can see over here, the Wi-Fi symbol is trademarked, and we can't do anything about it. However, the main problem with Wi-Fi is this. It's a standard. It's regulated in RFC as standard 802.11, and that's not the biggest problem, but the fact that it has 18 versions of it up to now, that might be it. Now, over here in this slide, you can see just a few of the standards regarding Wi-Fi. From the earliest ones, namely the classic 802.11, which had a maximum wireless speed, these are all wireless speeds, by the way, of 2 megabits per second, and it moved in the 2.4 gigahertz band. Speaking of which, where else did we see 2.4 gigahertz? Any idea? So we have 2.4 at the standard of 802.11, at 802.11b, G, we have it at N, and we have it here on Bluetooth, namely the same frequency band, which is free across Europe and some part of the US, is used by both Bluetooth and Wi-Fi, and that is one of the problems, and that is why we have channel interference on the pairing mechanisms of Bluetooth. Clear up to this point, or am I going too fast or too slow? Okay. Then I'll move along. So, one of the main issues regarding Wi-Fi is the problems of backwards compatibility. Namely, the newer standards, the ones that provide the most speeds, such as this one, don't necessarily have the possibility to accept older devices. Now, with 802.11 AD, that's not a problem because you can see that all of the generations beforehand were included and they can function. However, if you take the 802.11 AC, which is quite frequent nowadays, you can see that it runs on 5 gigahertz, and it cannot, for instance, run the 802.b, because 802.b only runs on 2.4 and AC runs on 5 gigahertz. And this is basically most of the theory for today's lab. Now we're going to walk and look at some tools and a general Wi-Fi router. Up to this point, is everything okay? Too fast, too slow? Okay, we're going to try to wrap it up in a maximum of 15-20 minutes from now, which I believe it's okay for you as well. So the Wi-Fi router is one of the most used devices nowadays. It grants us access to the network, and that is why it's usually referred to as an access point. It has a physical layer switch incorporated. They all do, whether your wireless router has, some of the Ethernet port in the back or not. You need to know that the information that splits in the local area network. So if you want to cast an image from your phone and send it to your smart TV, or from your computer and share it directly on a TV or a phone or something like that, you will use a physical layer switch. The information is within the same network, and as such, the information will be handled at a MAC addressing level. It also has packet filtering and parental access. Now, these two usually go hand in hand, and they're mandatory for nowadays GDPR, and not only that. Now, when we talk about networks, we notice that when we connect them, we use what is called an SSID. That is the network name. There are certain frequency bands that wireless routers can work on. You have 2.4 gigahertz, 5 gigahertz, and 60 gigahertz, just to name some of them. And you also have security. As you may know or remember, whenever you turn on, or probably when you turn on a Wi-Fi at your phone, try to log in a network, you're probably asked for your username and password. Now, those two are important, and they need security behind them. That security has multiple stages. The first one is none, which is always a bad idea. The second one is AAS or VPA2. Regarding Wi-Fi security, there is an extremely simple explanation and a way to remember it. The more letters you have in the security parameter, the better the security is. I know it sounds simple, it sounds stupid, but it works and it's true. Now, when you try to access a Wi-Fi, there's two methods to actually do it. The first one is passive, and the other one is an active method. The passive method implies that you just push on the Wi-Fi button on your phone, and you get a list of potential Wi-Fis. And that means that the access point or the wireless router will send on its frequency its SSID, namely the name, and the authentication method, namely in which way you should encrypt the password to access the router. The other way is the active way. I know it's kind of counterproductive, the naming, but that's the way it is. I'm sorry about it. When you use the active method, you turn on the Wi-Fi button, and that's it. No networks will show up. You have the option on most of your devices to input the name of the Wi-Fi by yourselves. And that way, if you know the specific SSID and the password and the encryption method, you type them down and you send them to the router. Has any of you encountered a hidden network before? Well, again, a hidden network is a network in which you can't actually see the network name when you turn on the Wi-Fi. So, and you have to type in the name and the password and so on. Well, that sucks for you. You don't have to worry about it. They're not all that common. They're good for security measures. Namely, if I don't want my Wi-Fi to be visible and as such the possibility of it being hacked, there is the option to actually hide it. And I'm going to show you that, to show it to you just in a few slides. Now, one of the tools that you can actually use for seeing Wi-Fi networks and that is acrylic Wi-Fi home. I am not going to go over these slides. You have some pictures and some explanations about it here. I'm going to turn on the Wi-Fi, the tool in a moment, but I want to go through the rest of the slides first, and then we can just go and play with the tool. This particular tool, namely acrylic, is useful for Windows and Mac OS. For Linux, there are other examples, such as a simple command line interface, such as Kismet. PRTG is also downloadable for Windows, and I'm not sure about Mac, but it's also available for Linux as well. The last part of today's lab, before we go on and play with the tool, is in regards to the configuration of a Wi-Fi router. Now, in the lab, we have two particular types of routers. We have Netis ones and we have Tenda ones. They're not the most expensive routers in the bunch, but they're nice to play with, and they have a pretty large amount of leniency when it comes to configuration. So whenever you turn on a Wi-Fi router, you probably hit the instant connect feature, the quick connect feature, the quick configuration one, and then you meet with two particular options. The internet setting, that means what comes from the operator, namely DG, Vodafone, Orange, you name it. And the wireless setting, because that's what you actually want, to have a wireless network. Sorry, again, long night. Now, when we come to the operator, there's three major options. The first one is the PPPoE, point-to-point over Ethernet. That needs a username and password. This particular method is used mostly by DG. There's the dynamic IP, which registers the router's MAC address at the operator. This method is used by Vodafone, Orange, I think Telecom, but I'm not absolutely certain about that. Yeah, it is. It is also used by Telecom. And the static IP means that you will receive from the operator an IP address and all of the parameters needed to configure the Wi-Fi. Now, this particular method, the static IP, is not really all that used. It's used in enterprise environments. It's used when you're trying to increase the coverage of your own home, but that's about it. Because when you do that, you need to make certain that whenever you have an access point, you know the exact parameters that it's logged onto. When you choose the dynamic version, that means that they operate on a DHCP method, and that means all the parameters are on lease, and they can change from time to time. And if you have, I don't know, a wireless camera, you're not really sure you want to change that particular IP. Now, When you go to the wireless settings in a bit more advanced, there's this one very important button that you need to make sure it's always checked on, namely the Wi-Fi on or off. I had people that complained that their Wi-Fi wasn't working and it and they configured it correctly and they sent screenshots. But look, we made and gave the password and schedules and everything, and it doesn't work. And that when I looked more carefully, I figured out that the particular button to switch on and off Wi-Fi was set to off. And what else is there but the small checkbox there that says hide Wi-Fi? Now, when you look at a Wi-Fi analyzer, you will see, and we'll see that in a moment, that there are um, Wi-Fi networks that can be hidden. When you see here, and we're going to look at this on a live session, so I'm going to turn on acrylic quite soon, you will see this network, you will see the MAC address of the switch you can connect to, you will see the power level, and that's about it. There are a few more settings that you can go to. You can have a schedule. You can select a wireless channel. You can select channel width. Now, most of these options are usually set to automatic, and the router will check for its own, for the best channel in which to launch its Wi-Fi. You can have limits, namely if you don't want people, I don't know, for instance, if you've got a kid or a brother that isn't supposed to, that's supposed to be actually looking to doing homework and not watching YouTube videos, you can limit his speed to web browsing, for instance, and not necessarily to HD videos. And you can have parental control in the sense that you can block the Wi-Fi during for several hours during the day, or and or slash and you can block certain sites. Now, before we go on to the tool that I wanted to show you, is everything clear up to this point? Is there anything you had no clue about? There are certain Wi-Fi analyzers that you can install on your phones, and they will specify whether there are more networks hidden or not. I'm not. Acrylic doesn't have Android or iOS version. However, there are several Wi-Fi analyzers that you can put on your phones, and you can check it with those. If you find one that actually does that, and you have time to actually check and see that, please give me a wink and I'll put it on the slide so that everyone will be able to know it. You're welcome. So in the 7 minutes that we have left, I am going to show you this particular tool. Again, it's not the best, but it's a free one. There is, of course, a premium version that you can pay for. I haven't. Uh, the information that I need is here. And here you can see that this tool gave me, I'll stop it for now. This particular tool gives me now all the Wi-Fi networks that are available in my home. So these are all the networks that my laptop can see and can attach to, including the hidden one. Now, when we look at this particular image, it's not all that difficult to figure out what it does. So it gives you the Wi-Fi name. It gives you the MAC address of the router that you can connect to. RSSI is basically a power level. So as long as, you can see here that most of the numbers here are in the negative part. That's because the power levels are written in decibels, which is, do you know what a decibel is? Have you ever heard of decibels before? Not necessarily for sound, but yeah, for signals. Whenever you measure signals, you don't necessarily measure amplitude or I don't know volts or watts. You can also measure decibels. It's not that much of a big deal of it, but there's a little logarithmic function behind it. So basically, if these numbers are negative, it's quite simple. The better the strength, the lower the number. So the closest to zero has the greatest signal strength. In the channel part, you can see the channels that the Wi-Fi's are connected to and have um, a central frequency. The maximum speed refers to the speed that is relevant to wireless speed. And you see here that you have connection settings. Now, for instance, on this particular network, which you see here, UPC Wi-Free, you see that there is no uh, absolute specific web encoding. However, you do have passwords protection and encoding using different algorithms. Again, the more letters you have in the algorithm, the better protected your network is. And in the last 3 minutes, the last thing I want to show you uh, is the difference between the 2.4 gigahertz band and the 5 gigahertz band. Now, 2.4, as I stated before, and as you probably saw in the slides, is the network used, is the frequency band used for most networks. And this is it. Let me just turn it on because it will be a bit more, it's alive, it's a living image now. You can see that all of the networks that are shown above, or most of them, are represented here. And we have the power levels of each network. We're in the 2.4 gigahertz network and we have the channels. You can see that 2.4 has 14 channels nowadays. 11 of them used mostly in North America, 2 mostly in Europe, and this is also included in the specifications. I've rarely seen or almost have never seen a Wi-Fi that sits on channel 14, but you can see that all of the networks here are present, and you can see there's 1, there's 2, this one's a bit larger down here, 3 and 4. This one we can't even see all. Oh, look, this is a nice one. FBI surveillance. You don't have to worry, I'm not being spied on by FBI as far as I am aware. So as long as this is the frequency band in the 2.4 gigahertz, and you can see that there's a lot of networks here, this is the way the situation looks in the 5 gigahertz band. Again, you can see the power levels, you can see the frequencies, you can see the channels, and you can see that there's a brown one, an orange one, and I don't know, some sort of green and a different type of brown, and that's it. So whether here we have, I don't know, 10, 15 networks, close to 30 if I'm not mistaken. Here we have extremely fewer of them. Now, this was what I wanted to share with you today. Are there any questions to what we discussed about? Oh, there's more of us now. So, are there more questions to what we talked about today? If not, 2 short messages. 1, please go to the virtual campus and check your attendance to this session. And 2nd, stay safe and have a great holiday. See you after the holiday. Bye.